Hello, good evening, guys. Hope you are doing well on a Saturday evening. Okay, so as promised, I will start my online lesson on chemical bonding. I really hope that once you finished watching this video, please like it so that I have an indication that you have watched it. Okay, like I said, please watch it within this week so that after that you have a better picture of how chemical bonding is like, and then you can start work on your 10-year series. Okay, without further ado, let's start. Alright, basically chemical bonding refers of two types of bonding for you guys in combined chemistry. The first one that we're going to touch on is ionic bonding. Okay, now before we talk about bonding, we have to talk about the notion of noble gases. Now, as you know, noble gases are elements that are in group 0 or group 8. It's at the extreme right hand corner of the periodic table. So noble gases are helium, argon, krypton, and so on. Now, why is it that we are interested in atoms of noble gases? Because atoms of noble gases, they are unreactive, or let's say they are very stable. That means they won't react with anything. Okay, they will hardly react with anything. They are not even interested in reacting with anything. So basically, when we talk about noble gases, all elements in the periodic table are looking or aspiring to become like noble gases. Okay, so that means when you talk about noble gases, you cannot have, let's say, like krypton chloride, no such thing, or helium sulfate. There's no such thing, because elements in noble gases, in the noble gases group, they do not combine with other atoms to form compounds. They are already stable on their own. So when you talk as when you see them, basically they exist as individual atoms, or what you call monoatomic atoms. Okay, so there's no such thing as diatomic or molecules when you talk about atoms of noble gases. Okay, so basically scientists when they discover noble gases, they want to find out why these elements are unreactive. Okay, the reason, if you look at it across here, okay, you have helium on the left hand side, okay, and on the extreme right hand side, you've got neon, argon, krypton, xenon, and radium. So basically, if you look at it, each noble gas will have a full valence shell. Okay, let's okay. Okay, let's look at it. Okay, if you guys realize, look at this. Okay, helium has one shell. Okay, so you look at the rest. Okay, the rest has two or more shells. Okay, so what's the difference? Basically, helium, as I always like to preach, if you guys can remember, okay, has one shell, so they will always occupy the first shell only need 2 electrons. Okay, so 2 valence electron, we call this duplet configuration. So elements that basically has one shell, I think you know these elements that have one shell basically has only 2 elements that only has one shell. Helium and hydrogen, okay, they need only 2 valence electrons because they have only one shell. So we call this duplet configuration. Alright, now how about the rest of the other noble gases? They all have 8 valence electrons, and they are very happy with having 8 valence electrons. We call this octet configuration. So the main goal of other elements in the periodic table are this: either if you have one shell, you aspire to have 2 electrons because you achieve duplet configuration. If you have more than one shell, then obviously you aspire to have octet configuration. Okay, so an atom is stable if it either has a duplet or octet configuration, and you call these two configurations a noble gas structure or noble gas configuration. So the dream or the goal for all elements in the periodic table is to have those two configurations. Now let's talk about why are the other atoms reactive. Okay, as I was saying, atoms react in order to have that noble gas structure. If it has one shell, okay, it wants to have 2 electrons. If it has more than one shell, then it wants to have 8. Okay, anything more, it's out of the syllabus. So atoms will tend to be reactive to either get, if it has one shell, 2 electrons. If it has more than one shell, needs to have 8. It needs to react with somebody. Okay, so basically they want to achieve this noble gas structure. They can do so by, if you're talking about ionic compounds, which we are going to go through in the next few moments, they will lose or they will gain electrons depending on who they are. Or if you're talking about covalent structure, which we'll go through in the next more slides, we'll talk about sharing electrons. Okay, so when atoms lose or gain electrons, they will form ions. That's how you get ionic compound. Okay, that's it. Okay, let's move on to the next slide. It's a very quick one. Okay, so we talk about ionic bonding. Okay, you need to know about the notion of forming ions. Now, atoms on its own, okay, basically you just have to refer to the periodic table to look at how the electrons are structured. Okay, atoms are electrically neutral because they have equal number of protons and equal number of electrons. If you have a periodic table by your side, which is recommended that you should do so, okay, let's look at sodium. Sodium has mass number of 23, okay, and if you look, there's a mass number is referring to the number on top, okay, of the box. If you look at the bottom left hand corner, okay, it has 11 proton number 11. Okay, so you expect the number of electrons to be 11 as well. Okay, so it balances it out. Okay, protons, remember again, if it's positive charge, electrons is negative charge. So when you talk about atoms being neutral, the number of protons and number of electrons are the same and they cancel them out from each other. Okay, so an atom becomes an ion if it loses or gain electrons. Okay, in an ion, the number of protons is different from the number of electrons. Basically, okay, either one of them is in excess. Okay, so an ion will always carry a positive or negative charges, different from atoms, because when you add on to it or when you lose the electrons from the atoms, okay, there's an excess now. Okay, let's look at it closely. Okay, so the general trend is this. Always remember, metals will form positive charge ions. There is no way metals can form negative charge ions. And you talk about positive charge ions, they are referred to as cations. Okay, so these are the common cations that we'll see. Sodium is Na+, magnesium is Mg2+, aluminum is Al3+. Alright, non-metals, in the other hand, will form negative charge ions, and you call them anions. Okay, and the common anions that you'll see is your chlorine. Okay, will become chloride ion. Oxygen will become oxide ion. Sulfur will become sulfide ion. So please, some of y'all are still very confused. You still refer chlorine as chloride and chloride as chlorine, so don't mix them up together. They become, for chlorine, okay, that refers to the atom. They becomes chloride when we talk about ion. Okay, it's as simple as that. Same thing with bromine and bromide, iodine and iodide, so on and so forth. Now, how do metals become cations? Atoms of metals, remember again, they have usually, when you refer to metals, they are talking about group 1, group 2 and group 3. So they tend to lose these valence electrons to form positive charge ions. Remember again, the goal is always to achieve 8 valence electrons. So for metals to have 1, 2 or 3 valence electrons, to get 8 valence electrons, don't think that, oh, if I have 1 valence electron, I need to add 7. It's unrealistic, because to add or to lose, it requires energy. So imagine if I have 1 valence electron, which one would I rather do? Do I lose 1 and basically get my inner electrons, okay, because my inner electrons obviously have 8, or I gain 7, okay, and then I'll get my 8 valence electron? I'll probably take the easy way out and just lose 1, right? Okay, so that's that. So usually metals will lose valence electrons to achieve noble gas structure. Let's look at this sodium ion. Now, as I was saying, sodium atom has 11 protons and 11 electrons. Okay, so you draw. Some of you still have difficulty drawing the dot and cross diagram. Again, to draw dot and cross diagram, the first shell will always have 2, then followed by the second shell will have 8, and then followed by the third shell if it has 1. Okay, so altogether this 11 electrons. And then its electronic configuration is 281. So obviously you have that one valence electron there extra, and obviously your goal is to form an octet structure. So you will lose this one valence electron to form a sodium ion. Okay, so when it loses, okay, now what happens? Okay, when it loses, now you have 11 protons. Imagine you have plus 11. Okay, and then your electrons, because you have already lost one, now it has become minus 10. Now plus 11 and minus 10, so altogether you will have an A plus. That's the reason why your charge now is plus, because now you have an excess of protons instead. Okay, I hope you understand this concept, because some of you all think that, oh yeah, I lose one valence electron, then obviously I'll become Na minus because losing is minus 1. That's a very wrong conception to remember. Okay, always remember, for this case, if you lose one electron, it will become plus. If you gain one electron, then vice versa, it will become minus. Okay, let's move on to the next slide. Okay, so your formation of sodium ion will look like this. Okay, it will look something like this. Of course, when you draw it in your exam, your center of the atom, okay, I expect it to be here, this one that I'm talking about. Please write like this. Okay, and please have the charge and your brackets. It's very, very important. Okay, some of you all, it's a disgrace, it's a way you all did in prelim 1. You all still do not know how to draw your ions. Okay, so don't do that. Okay, let's talk about calcium ion. Okay, now calcium ion is slightly different, but roughly the same pattern. Again, calcium atom has the electronic configuration of 2882. How do I derive from there? Because calcium atom has altogether 20 protons. So from 20 protons, you know, it's neutral, it's 20 electrons. Okay, so you have 2 valence electrons here. You will lose 2 valence electrons to form, okay, Ca2 plus. Okay, it's very easy. So basically the group number will refer to how many electrons you will lose when it forms an ion. So group 1 will always form a charge of plus. Group 2 will form a charge of 2 plus. Group 3 will form a charge of 3 plus. But it can only stop at 3 plus. Remember, when you talk about metals, it's plus. Group 1, group 2, group 3. Group 4 is no longer a metal anymore. Okay, now let's talk about anions. How do non-metals become anions? If metals lose electrons, non-metals will gain electrons. Now let's look at chlorine atom, I believe. Okay, chlorine atom has 7 valence electron. So 7 valence electron, is it easy to just lose that 7 valence electron, or is it easier to gain one more electron to become octet structure? Obviously it's easier to gain one more, right? So you gain one more. Okay, so you gain one electron to form, okay, a charge of Cl minus. Okay, so for your exam, okay, always remember, again, I reiterate my point again, the center, at the center of the atom, please write your chemical symbol. Okay, this one, okay, is better if you write it as X, okay, to represent incoming electron. Okay, and then here you have your negative charge, your brackets. Okay, always when you talk about ions, you always talk about the bracket. Okay, and I believe there's one more atom. Okay, this time around is the oxygen atom. Oxygen atom is 2,6, electronic configuration of 2,6, it has 6 valence electrons. So to form the octet structure, it needs 2 more. Okay, so it will form O2 minus. Okay, again, let's look at your your incoming electron. Make sure you draw cross, okay, to symbolize an incoming electron. Make sure you have 8 valence electron altogether. Brackets, charge. Okay, very easy stuff. Again, like I said, these slides basically serve as a revision for you. Alright, so common ions and their charges. Okay, the ones that you need to memorize, okay, are usually, okay, so basically I think I showed you all, I showed you all how to remember which one are the common ions that you need to memorize. One is ammonium, Okay, the other one is silver. Okay, let's see. Okay, other than that, okay, that's about it. Hydrogen. Okay, so these are usually the ones that is very difficult to decipher from your periodic table. Fe2 plus, Fe3 plus will form more than one ion because they are transition metals, so that's fine. Okay, now let's look at the anions. Okay, anions slightly more that you need to memorize. Okay, other anions you can just represent it, you can just decipher it from the periodic table. One is hydroxide ions. Okay, another one is nitrate ions, and the other one is carbonate and sulfate. Again, please take note, sulfate is spelled with an F, not a PH. This one is old slides. The rest all you can just refer to the group number, and then you can just get their group your periodic table. Okay. Okay. That should be done for this set of slides, hopefully. Yep, I'm right. Okay, now let's refer to the third slide. I hope I'm not going too fast for you guys. Surfing through Facebook, working on a weekend. I hope you guys put in the same effort as I did. Okay, so when you talk about ionic bonds, alright, now remember when you talk about ionic bonds, I always emphasize to you guys that ionic bonds is always the metals reacting with the non-metals. That's how ionic compounds are formed. So let's say if sodium, a metal, reacts with chlorine, it will form an ionic compound called sodium chloride. Okay, so what are the three steps involved in the formation of ionic compound? Again, you have formation of positive ions. Okay, that's where your metals, remember, your metals will get positive charge ions. Your non-metals will then gain electrons to form negative charge ions, and then you put them back together. Okay, so your formation of positive charge ions, I think this is a quick one. Basically, your metals will always lose their valence electron to form a positive charge ion. So in the case of sodium has one valence electron. It will lose this electron to form a positive charge sodium ion. For chlorine, okay, remember chlorine has 7 valence electron, so it will gain 1 valence electron to form 8. Okay, 8 electrons. And then basically if you have Na plus and Cl minus, you go back together, and the attraction between the positive charge and the negative charge is called electrostatic attraction. Forces of attraction. Okay, remember or not? Okay, when I went through the bonding for 10-year series, this part is very, very important. You need to know the name that exists between the ionic bonds. Okay, that's it. Voila, simple. Okay, so this is how you represent your dot and cross diagram. I believe during the exam you just need to know how to draw this. Okay, you do not need to show the transfer and all that. Don't need. It's okay. Okay, this one is the more important one. Okay, the bracket and all that. Again, please take note. Most of the time for 10 years, for exam questions, they always ask you to draw valence electron. But sometimes they didn't ask. They didn't say anything. So when they didn't say anything, you need to draw all your electrons, inner electrons as well. Okay. Now, okay, so your dot will represent your electrons of one atom. Your cross will represent the electrons of another atom, and you must indicate your electron that is transferred. So in this case, your sodium electron that is transferred to the chloride, right? You must represent it still in the symbol of sodium formula. Okay, so this one shows this one shows your magnesium chloride, formation of magnesium chloride. Okay, again, your magnesium loses its 2 valence electron, transfer it to chlorine atom. Now, why do you need 2 chlorine atoms? Because one chlorine atom just needs 1 valence electron. Your magnesium wants to give 2. Okay, so even if they can get one more, okay, if they get one more, they become unstabilized. Okay, so basically you just need 2 chlorine atoms to accommodate the 2 valence electrons that the magnesium is losing. And then after that, okay, your chlorine will gain 1 electron to become chloride ion, and then you have this electrostatic attraction. Now I just want to highlight one more thing for for this part. You see, the slides purposely place the chloride ion, okay, in between the sodium, at either side of the magnesium atom, magnesium ion. This was made in a conscious effort because if you remember, okay, you can't put the negative and negative or positive and positive side by side with each other. Why? Because if you can recall, the electrostatic attraction is between an attraction between plus and minus. If you put minus and minus side by side with each other, then there will be repulsion, correct? Okay, so when you draw your ions, please take note, do not draw your negative and negative or positive and positive side by side from each other. If you want to place one negative, okay, on top here and the other one here, okay, it's fine. Okay, it's still quite far apart. Okay, but please do not put them side by side. Okay, not recommended. Some markers are very, very fussy. They might just penalize you for that. Okay, now that ends our third slide. Okay, I'm going through for 21 minutes. Hopefully I can finish this through. Alright, some people say I'm becoming a bit long-winded, but really I've got no choice. Okay, so this one is 6 slides, okay, so just bear with me for this. Okay, now your chemical formula of ionic compounds is derived by balancing the charges on the positive ions with those on negative ions. Okay, so I feel that it's very important to go through this part because some of you are still clueless on chemical formula. It's very, very evident, especially for your previous prelim. So let's say if you have magnesium and oxygen, okay, magnesium ions will form Mg2 plus, O2 minus will form O2 minus, of course. So you bring them together, you'll form MgO. Okay, fine, you have 2 plus and 2 minus, it will cancel off. Now let's say if you have, okay, if you want this, okay, another way to come up with an ionic compound formula, okay, is you draw the charges and then you cross diagonally. Okay, I think I taught you this method before. So it just brings down, okay, the here M you just bring down to the subscript and we just bring down without the charges, without the charges. Where did the charges go? When you bring the two ions together, the charges have already been nullified. Okay, so that's how you get it. This is just a cross multiply method, cross method lah, basically you call it. Okay, so what I'm talking about, basically if you have copper 2 plus and OH minus, okay, this one better be careful, okay, if you cross the numbers, okay, it becomes Cu and bracket OH2. Okay, not, okay, your polyatomic ions need to be enclosed within brackets if the subscript is 2 and above. Okay, you cannot have like this. Okay, I think I emphasized this during class so many times. Some of you all get caught out in the whole situation. You write like this. This one indicates that the 2 belongs to the hydrogen only, which is wrong. Okay, so basically you need to have your brackets. Alright. Okay. Now, what is the chemical formula for aluminum oxide? Aluminum oxide is the worst thing that you can ever get. You have 3 plus and O2 minus. So you just exchange the numbers and then you form Al2O3. Okay, simple stuff. Okay, some of you all please, like for example, calcium carbonate. When you talk about polyatomic ions, it becomes more tricky. So for calcium carbonate, again, there's no difference. You have 2 Ca2 plus, CO3 2 minus, both same number. So you just bring them together. Okay, but please do not write it like this. 2 is a common factor, so you cannot write it like this. So don't need to put brackets. Okay, so please take note. Do not write it this way. Okay, cancel. Okay, because the 2 is the common factor. As long as the same number, the number is the same, the factor is the same, you can just bring them together. Okay, voila, we're done, right? Yeah. Okay. Off slide. Goodness, now I'm getting sleepier. Alright, bear with me on the ionic compounds. This one is 3 slides. Okay, it's very simple stuff. Now, ionic compounds are formed from giant ionic structures. So, if you look at the whole structure, you zoom out a bit, this is how the structure looks like. Sodium chloride, okay, commonly known as our table salt. Okay, the structure looks something like this, okay, and it looks very squarish, and you call it the giant lattice structure, a crystal lattice structure. Okay, so in a lattice, you have millions of sodium and chloride ions arranged in a orderly manner. Okay, so if you can recall for your solids, okay, the ions are all just vibrating about in their fixed position. So they are all held together through this whole regular structure called lattice. Okay, so if you look at it, each sodium ion is surrounded by 6 chloride ion, and vice versa, each chloride ion is surrounded by 6 sodium ions. So if you look at it, 6 to 6, the ratio is 1:1. Of course, if you're talking about magnesium oxide, then it's not magnesium oxide, sodium oxide, where Na2O, right? Okay, then the ratio is Na to oxide is 2:1. So obviously, you will have that kind of ratio. Okay, so that's that. For structure, you don't need to be so caught up with it. You could just read through it, get to know about it. Very seldom they like to ask you about the crystal lattice structure. Okay, so it's on a need to know basis. Okay, the last one that we're going to go through is on properties. Properties is more important. They like to ask that in section B, paper 3. Okay, so we talk about volatility. Okay, volatility is just a new word. Probably you will recognize. It just means boiling point and melting point. Okay, so we talk about these 3 properties only: volatility, solubility, and electrical conductivity. Usually they like to ask about volatility and electrical conductivity. Very seldom now they ask about solubility, because solubility you don't need to know the reasoning behind it. Okay, now without further ado, let's talk about it. Now, before I talk about electrical conductivity, please, I just want to talk to you about molten. Remember again, molten means melted. So when you talk about molten, usually is in liquid state. There is difference from aqueous. Aqueous, you take a solvent, you dissolve in it. For molten, you just have to melt it. Okay, they are 2 different things altogether. Okay, so for aqueous, is dissolved in water. Molten means it's melted from the solid state itself. Okay, so when you talk about volatility, very, very, very important. The lattice of the ionic compound is to get held together by strong ionic bonds between the ions. So you need to have a large amount of energy is needed to break. Now, again, there's a slight error here. I do not like to see the word strong ionic bonds. Remember again, I always like to see the word strong electrostatic. Please, it's one word, sorry, no space. Force of attraction. Okay, that is the exact way you describe the attraction between the positive and the negative. Strong electrostatic force of attraction. Sometimes in 10 series they like to write strong ionic bonds. Please do not be fooled by the answer in your 10 series. If you're not sure whether the answer is correct, please ask me. Okay, I know the current 10 series that you like to refer that sometimes the answers they talk, oh, strong ionic bonds, then some of you thought, okay, maybe can. Okay, it is wrong. If you write it in prelim exams, it is wrong. If you write it in your what do you call this, your O-level exams. Okay, so 2 points that you need here. There is strong electrostatic force of attraction between ions, and you need a large amount of energy needed to overcome these bonds. A common misconception, again, I think I've covered it. A lot of you like to talk about between the molecules. You talk about between the molecules, the marker will straight away penalize you. Okay, so do not write that down. Okay, that's why you have a large amount of energy needed to break the bonds. Usually for ionic compounds, they are solids at room temperature pressure. Okay, and they have high melting point and high boiling point. Okay, so when you talk about volatility, okay, when they have high volatility is opposite of boiling point and melting point. If you have high melting point, high boiling point, then the products are non-volatile, okay, or low volatility. Now, let's talk about solubility. Ionic compounds are usually soluble in water. That means they can dissolve in water. Okay, but when you talk about organic solvents, okay, I think by now you should know what's organic solvents. Ethanol, petrol, and turpentine. Okay, they are insoluble. Now, how about electrical conductivity? in aqueous solution, or let's say in aqueous sodium chloride, we just take the table salt, you add it to water. Let's see how it tests out in terms of electrical conductivity. Okay, you see that the light bulb will actually light up. Okay, so that means it can conduct electricity. However, if you talk about it in terms of solid sodium chloride, you just take salt, then you just immerse it in the electrodes. The bulb does not light up at all. So what does it show you? Okay, in molten sodium chloride, let's say you just take that sodium chloride crystals, right, that table salt, you melt it. Okay, you melt it, and then you realize, now the light bulb lights up again. Okay, what is actually happening? Okay, so for ionic compounds, always remember, okay, they do not conduct electricity at all in solid state. Why? Because they do not have mobile ions. Okay, so when an ionic compound is melted, that means you take it from solid, it melts it to become liquid, or you dissolve it in water, then it can conduct electricity. Now, why is it that they can conduct electricity? Because now the ions are free to move. Okay, please do not confuse this with electrons. A lot of you like to talk about ionic compounds can conduct electricity in molten or aqueous state because of delocalized electron. No, cannot. Only mobile ions. Okay, so the free moving ions conduct electricity. Okay, that's why ionic compounds can conduct electricity only in aqueous or molten state. Okay, that's all for properties. It's very easy. So the properties that you need to know is in terms of melting point and boiling point and electrical conductivity. But if they ask you, what are the other properties that ionic compound have, you can bring in solubility as well, just as a state. Okay, so that one is no problem. Okay, are we done for ionic compounds? Yes, we are done for ionic compounds, and that's that for ionic compounds. Stay tuned for the next video where I will talk about covalent bonding. Okay, for now, see you.